Hey everybody, this is Larry. This is day 23 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Sort the matrix diagonally. So I usually solve these live, including the explanation. So if it's a little bit slow, fast forward, or just, because I like you to kind of think about or hear about my thought process and see it in general. So, okay. Sort the matrix diagonally. A matrix diagonal is okay. So there's some matrix, and you want to sort each matrix, and then return the resulting array. I think I solved a similar problem recently. On the Leetcode contest. I think this is just an implementation problem, right? Because I don't think there's anything like conceptually hard about it in terms of like thinking about what you need to do. It is all implementation. And the key thing to note about the diagonals is kind of labeling the diagonals, and this is something that you just, for me, you get from practice and experience and so forth. So it may seem like I know this immediately, but that's because I've done it before, right? Or similar problems before you, because I think I probably done this during a contest, and if so, I'll leave a link below so you could see me that time, because maybe that's less fresh. But even then, my thing is that like I've solved similar problems, so then you're able to label these diagonals in a good way. And the way to label the diagonal is that okay, so I'm trying to figure out what's the best way to visualize, but the idea is that okay, so you have a matrix that starts at 0 0, 0 1, 0 2, 0 3, and so forth, and then you have 1 0, 1 1, 1 2, 1 3, and you get the idea here really. But I just want to draw at least to 1 and just a little bit more. And then the idea here is that you look at these as x and the y. Each diagonal going this diagonal will have the same x minus y, right? So for example, this is 0 because they're the same. This is -1, this is -1, this is this is -2, this is 1, and so forth, right, for that diagonal. So you kind of do it that way. And again, as I said, there's no trick to this other than either experience, and if you have seen someone done it once before, then you're like, oh, and maybe it doesn't, maybe it takes a couple of times of practice before, you're like, okay, I've seen this a few times, so I should get this. But so don't, even if you have seen it before, it's okay to not think about it. It doesn't come up that often, to be honest. So yeah. So okay, so that being said, so now we should just we should just sort it, right? And as I said, this becomes an implementation problem. There's a lot of different ways to do it. I'm going to do it the way that you'll see me do it, which is that I'm going to put everything in the hash table, and you don't actually, and then sort. Like we have a hash table of lists, and then sort the list, and then reconstruct the matrix that way. You actually don't need the hash table. You could have an array of an array instead, and you could probably do some funky math to do it in place if you want to do it in place. But definitely, I would, especially during a contest, and maybe even during an interview, I might mention that. I think during an interview, to be honest, you probably wanted to do it in place, for, even though usually you don't for a lot of functions. But for sorting, I think this is one of the few things that it makes sense to be doing in place. So for upsolving, after you get the concept and implementation, after you be like, okay, this is good. After you have a good working one to base off, feel free to kind of do it in place. And it's not impossible, it's just annoying, and because you have to implement the sorting yourself, probably. Yeah, I mean, I don't see an easy way to do it with libraries, but I could be wrong. If you have an easy way to do it with libraries, leave me a comment or just send me a Discord message. I'll be like, oh, that's actually a pretty cool solution, or something like that. So let me know. But yeah, so again, I'll have just like I'll use a storage here. So I'll be like D is equal to, I don't know, collections dot default dict of a list, and D is a terrible name, so let's just it's like a temp dictionary lookup. So let's just go lookup. All right. And again, you could actually replace this in a way because by just doing simple math on the number of rows and columns, because then now you know what the minimum number is, which is rows minus columns, and then what the maximum number is, which is columns minus rows, or something like that. Maybe in reverse. But I'm just gonna use a lookup table because I'm a little bit lazy. Oops. I always let's call it matrix. I don't know why they just as for consistency's sake. Let me see that this has at least one element. Otherwise, I have to do that check. Yeah, and then now just for X in range of rows, for Y in range of columns. We do look actually, and I actually want this to be. I want to say I want this to be a deck, but maybe I could actually do this after we sort. No, I mean, because so then I can. You can also keep track of indexes, actually, I guess. But yeah, we'll play around with that. I think the implementation is not that, but yeah. So I would have something like this. I actually don't remember the way that I did it last time, so maybe I think we'll do a quick scan afterwards to see how Larry did it last time, because I think that has happened the last couple of daily problems, and it's interesting because sometimes I do exactly the same thing, including the same mistakes, and sometimes I'm like, wow, previous Larry did it the smart way, or I was like, oh, previous Larry did it the dumb way. So it's hard to say. So yeah, so now for each key value in lookup items, we sort it, and that's pretty much. And then now we have to populate the matrix back. Actually, what I want to do is we want to sort it, and then actually let's write this a little bit different. For lookup keys, lookup key is we sort it, and then I want to convert this to a deck so that I could take it off the front without. I mean, and of course, all these does take time and space, but it's still, not the dominating factor. So I wouldn't worry about it. And you could say that but especially during a contest or something, I would, be careful or just think about doing it as quickly as possible. So that's what I would think about. And again, if during an interview, you probably want to do it in place, so it's probably something that you want to practice in. But don't assume that. Make sure that you communicate with your interviewer. Be like, hey, I'm doing XYZ. Is that okay? Right? Like, so don't make assumptions as much as you can. But yeah, then now we go back to, populate the thing. So then now matrix of XY is just you go to lookup of X minus Y dot pop left. And then now we can return matrix. And yeah. I might have to. They only gave us one example. Okay. It looks good. I wish they gave us another example, but I mean, maybe I'm confident about it. So let's give it a submit. Cool. Yeah. So what is the complexity of this? Well, this is going to, as usual, dominate by the sorting, and the longest diagonal is just going to be one of the diagonals. So it's either going to be rows or columns, probably min of rows times columns, min of row or columns, log that. So if you have, say, R is equal to the number of rows, C is equal to the number of columns, then the worst complexity is just going to be O of R log R. Is that right? Yeah, I guess so. Plus R times C, because that is the size of the input. Or in this case, this is if rows is less than columns. And of course, you could also just, swap R and C if it's the other way. It doesn't really matter. And in terms of space, for each item, we put everything in a lookup table. So it's going to be linear space because each item appears once in the original. Every item that appears once in the original matrix appears on, in this lookup table once. So yeah, so this is linear space, and this R log R time, which I don't know. To be honest, I'm not sure which one dominates because this is actually the min of R and C. I mean, in theory, this should. I mean, yeah, this is. if this is a square matrix, then clearly the R squared dominates, even though that's linear in the size of the input, of course. So yeah, I don't know. So I guess maybe this is just R times C, because if otherwise, then this actually just gets disappeared in either case. I could be wrong on that one. Let me know what you think. Because for example, if C is equal to 1, then actually this is just 1 as well, right? So it doesn't, then it gets dominated by here as well. So actually, I think maybe it. If y'all have any different opinion, let me know. But I think this is just linear time, linear space. And to be clear, when I say linear, I mean linear as in the size of the input, which in this case is R times C. Which some people say is quadratic, but its size of the input is R times C or n squared or whatever you want to call it. So in that case, then it is linear, even though the complexity is n squared. Anyway. It depends on how you define the variables, but it's linear in the size of the input. So okay, let's kind of take a quick look. See if I done it last time. I think I did last time. If not, then we're just wasting a little bit of time then, and I apologize. But I feel like I've done either this or similar problem. So yeah, let's see how past Larry do it. I'm just curious in general. Let me know what you think about this segment, because I don't remember every problem, so I don't even try to look it up. So I actually did this, actually almost exactly a year ago. I don't know. They could have waited 2 days and it would have been a year exactly. How did a year ago Larry solve this? Okay, let's see. Oh. Okay, so I think, essentially I did it the same way, but instead of using a deck and pop off the front, I did this list popping off thing, which is, I think, in theory, slightly more expensive. But I don't know. But that is a language specific thing. But I essentially did, at least in concept or at least in idea, the same thing. So I'm happy about that. Did I do this during the contest? I don't know. Oh, I guess I did during the contest, and you could see. Well, I'm just curious how long I took that time as well, because that was a year ago exactly. Wait, before I go on the trip. Oh, this. Which one was this one? Is it Q2? No, Q3. Okay, so I did it in about 5 minutes, but I didn't do Q4. Oh, and it's a 10-pointer, so I guess it was a very hard one, but I don't remember. Anyway, this is more relog than solving this problem, but possible. Oh, I still don't know that I mean, I definitely solved it eventually. Okay, I was wrong. I didn't. Did I just give up on this one? I have to think about this one. Anyway, it's totally unrelated, so I don't know. Let me know what you think about this problem. I will see you tomorrow, and bye-bye.